Okay, guys, good evening. Can anyone acknowledge me whether I am audible?
Yes, sir.
Okay, fine, fine. Okay, good evening, everyone. So today's session is about computer vision. So before starting, does anyone have any idea what is topic all about computer vision? Does anyone have any idea? Okay. So computer vision is what? It's a branch of computer science. Okay. So what does it the what is the main role of computer? If I put a definition of computer vision, so we can say that it empowers the machine to see, recognize, and process and render the different images just like humans. So you would be wondering, what is it? Just 1 minute, let in. So you would be wondering what was the actual meaning of this definition. Suppose there are two images. Okay, let me show you so that you can understand. Okay, can you see these two images?
Yes, sir.
Okay, so we can distinguish these two images. On the left hand side, it's a dog, and on the right hand side is a sheep. But how we can distinguish? We can distinguish because the different the functions of their shape, size, but machine cannot distinguish. It don't have so much of adaptability. All right. So that is the main role of computer vision. So what is the definition says here? Empowering machines to see, recognize, process just like humans. So there are different low level of images. Suppose the alphabet 9. Let us consider the alphabet number 9, 6, 7, 8. So if the images is in very poor quality, then we will use different algorithm to identify the actual number, whether it is 9 or 6 or what so on, what is the number, actual number it is. All right. So, what is a computer vision? The definition says computer vision is a branch of computer science that empowers machine to see, recognize, and process just like human beings. So they can distinguish the different objects and different things. All right. But one thing we need to distinguish that computer visions, all the data sets that need to be labeled while processing, all the data set need to be labeled. So in the previous session, our trainers has already told you what is labeled data set, isn't it?
Yes, sir.
Okay. So the main objective is to understand the digital image through the advanced algorithm and machine learning techniques. So we will be using different algorithms such as CNN. Yesterday also our different teachers have gone through the different algorithms, CNN, RNN, then AN. So those algorithms we will look into it, and we have different some projects also today. It's very interesting. So we will upload some of the images today, and we will try to figure out what is the actual images. So as I have shown you this picture, in this picture there is a challenge. So machine cannot distinguish whether it is 90% of the algorithm in the first picture will like distinguish as a sheep because of their color and size and shape. It will identify as sheep. But advanced algorithm such as like transformer model, they will 100% they will distinguish that this is not a sheep, this is a dog. Understood? Any doubt?
Yes, sir.
Okay. So key characteristics. So it's a multidisciplinary field combining AI and machine learning. It's used general algorithms and specialized method, borrows techniques from engineering and computer science field. So challenges for the computer. What I was saying you that we have some natural gift of vision and perception. So we have the perception that whether it's a like tiger or it's a cat and different like objects we can classify, isn't it? We don't have any type of confusion. Suppose if we see a chair and table, we can easily distinguish which one is chair, which one is table. But machines, it's need to be labeled. We need to label the data set that this is it. We need to label and train the machine that this is chair, this figure, this is chair, and this is table. Then only machine can identify, isn't it? So seeing and perceiving some naturally and intrusive understanding of the visual world. So in our real world, we have different things. We can visualize different objects, different things, isn't it? So the machines, we need to make them understand the things which we have like created, human have created. Suppose laptop, computer, any devices, electrical devices, we have named it. Machine cannot name itself, isn't it? So different objects, we need to label them and make the computer understand the different like different objects. So what computers cannot do, they don't have the gift of vision or perception. They cannot don't have a perception whether the what is the actual object is. We need to train them, human need to train them. Understanding the digital image is not a intrusive, must be taught to see through the complex algorithm. Yes, we need to make them understand by using different algorithms. There different false alarm. What is false alarm? I will tell you. I will show you with the example. We have some algorithm in the programming part. So if we use this figure, if we upload this figure using CNN, convolution neural network, they will identify as 80 to 75% as sheep. So that's a false alarm, isn't it? Whether it is a sheep or what, is not a sheep. This is a dog. So the false alarm we need to like omit, isn't it? So that is the biggest challenge we have. Requires extensive training and specialized methods. So therefore, in the time to time, we have advances, different techniques and different methods. Now we have like accelerate a much of the things, and we can label the different objects, and our results are far better from previous challenges have already overcome. So this is the example I have been showing you. Humans and machines distinguish between the white dog and a white sheep. It's very challenging for the machine to distinguish between a white dog and a white sheep. And another similar object also, it becomes very like difficult for the algorithm by using the simple algorithm to distinguish different objects. Okay. Human instantly recognize differences. Yes, we humans, whenever at the first glance, we can identify the object, whether the object is a dog, sheep, or any other object it is. We don't need to make ourselves understand. At the first instance, we can identify those objects, isn't it? So people can easily tell a white dog from a white sheep by noticing features like shape, face shape, air portion, fur texture, body structure using experience or intuition. So there are different like parameters are there. By noticing those parameters, at the first glance, we can distinguish the different objects. All right. So machine need to label the data. So what machine need to do? Machine need to label those datas. Computer cannot see or understand the difference naturally. We need to make them understand. Okay. They require thousands of label images of dogs, sheep, and learn their unique patterns of features of the each. So by looking at only one dog, if we see only the previous example, suppose by uploading and make understand only one picture doesn't make the machine learn that distinguish whether it is a sheep or it is a dog. We need to upload thousands of different images of the dog. Okay, we need to make upload thousands, more than thousands, to understand the machine by categorizing different features. I will show you how it categorize later on, but we need to upload a huge bundle of data set of the similar characteristics of a dog. Then only machine can understand. Training enables machine recognitions. Yes, whenever the label that data is been labeled, we need to train them again and again. We need to train them. Suppose the portion of the nose, head, leg, tail, we need to separate and we need to train the machines again and again, so that machine can recognize at the first instance and give us the result whether it is a dog or it is sheep. So only after being trained a large data set, a machine can accurately distinguish between a white dog and a white sheep by identifying learned patterns in a new images. Then only we will get our result. How computer vision algorithm works? Yes, there are different algorithms we will use today. So first algorithm which we need to know, it is convolution neural network. Okay, so that is a one you can say model or a method where we can distinguish the different patterns. Actually, the computer vision is nothing, a pattern, it's sort of pattern recognition. There should be a pattern so that we can understand different category of objects. Have you understood? Have you got something? What is computer vision?
Yes, sir.
Anyone? Okay.
Yes, sir.
So first step, how we will know using CNN. So first of all, step one, train computer on enormous amount of visual data. Suppose we are classifying any object, suppose a figure of a tiger. So we are taking a figure of a tiger, different images of a tiger. Okay, different. So there are different Bengal tigers or there are different categories of tiger, isn't it? So we need to train the machine that these are all are different types of species of tigers only. We need to render and like lots and lots, large amount of data and label them as a tiger. Process the image with label various objects. Yes, we need to label them. Find pattern in those objects and we need to find a pattern. So in different categories, there is a pattern. So in tiger, there are like eyebrows, their limb, their legs, there are different distinguished features are there, so that we can make that machine learn that this is not a lion or not any other like animal, it's only tiger. Okay, create representative model and accurate decision. So we will create a like representative model and we will get our result. So for example, million of cats of image. So we are creating, we want to distinguish different types of cat. Okay, so what we will do, first of all, we will take the millions of image of cat. Okay, analyze the pattern. We will break it down. So we will break it down and we will break and understand the pattern, then create a model cat. So we will break, suppose the head part, we will break all the images, we will break into like all the heads, we will break into like different patterns. Okay, then tail we will break, everything we will break into different parts and we will understand the different models. And after combining, we can understand that this is the cat. I will show you how does it work. So just a minute. Okay. So CNN model, I have like in the next few slides, I will show you how does it algorithm exactly works, but with the health representation of a neural network. Okay. So training example and pattern recognition. So as I have already told you that CNN models goes hand in hand with the pattern recognition. It needs some kind of pattern. So first of all, the training process. So again, the same thing has been written up. So what we need to do, we need to send a millions of images of the cats on the computer. Then what it will be do? It will analyze, examines all the process of the images. They will find some sort of like what patterns of similarities between them among themselves. Then it will create a model and then we will get a result. So what type of result we will get? Result can be accurately detect whether the image contains a cat. Suppose we are uploading another image. We have made a data set, suppose X, and we have uploaded a different image of like Y of a cat, which is totally new. Suppose fresh image. It doesn't contain in the data set. Now we want to find out whether the new that image whether it is cat or not. That's our part, our result we need. So it will render different image, it will find the pattern, will be pattern recognition will be done, and it will get the result that it is a cat by distinguishing different features extraction. Improvement, continuous enhancement with the more training. So by the time whenever we train n number of data set, it will enhance automatically. Okay, and it will give more accurate result. Speed, near instantaneous recognition. Yes, the speed is very high because if we use some traditional methods such as CNN and NNN, their complexity of the algorithm is very low. Okay, so that's the reason the speed is very high. Whenever the algorithm's complexity is low, we will get a very good result in terms of speed. Okay. Scalability applies to any object in category. Yes, scalability is another like thing it need to be overcome. Scalability is the number of size of the objects. We need to render the n number of label data set. Okay. Visual data exploitation, computer powers, and advanced algorithms. So we will be using image dominated in internet today, presents everyone in social media, e-commerce, travel websites. So if we see the advantages of computer vision, it can be in different ways. In e-commerce, travel websites, social media, everywhere computer vision are being using practically day by day. Computation power, easy access to computation power for data analysis, for analyzing different data, it becomes very much important in today's world. New hardware solution available, cloud computing accessibility, and advanced algorithm. Yes, as I have told you, in methods like CNN, there are very much of false alarm are there. I will tell you what is false alarm. Already have told you with the help of example. I will show you some of the examples in programming part that what is false alarm. But today's algorithm, it is little bit complex, but the result is very much like accurate. Breakthrough improvement and accuracy, continuous innovation cycle. Yes, from the timeline from CNN to transformer model, it is a continuous innovation cycle. We have accelerated the accuracy level. The enhancement is there. So this is what I was talking about. Just a minute. Phenomenal improvement less than a decade. So if we talk about a decade, previous accuracy was just about 50%. Okay, so previous it was a very challenging part for ourselves for showing the same color of objects. It becomes very difficult for the machine to learn and give us the accurate result. But today we are getting 99% accurate. How? I will show you. Today's system are more accurate than human. Yes, today's perception of categorizing different object are more like accurate than human. Computers react much faster than the humans and visual input. Yes, computers are very much faster than humans, and they can give like very accurate result. Fields has grown exponentially in years. So the fields, the applications has been grown exponentially. As I have told you, we can use in e-commerce and different like applications are there. Higher accuracy rates for the object identification have achieved. So in last few decades, our achievement has grown in accelerate very much. So this is the historical timeline. In 1950s, early beginning. So early beginning of the pattern recognition has become from 1950s. Just a minute. Sorry for the interruption. So 1970s, fast commercial use. So after 1950s, the gradual development were there, research has been done, and fast commercial use has been done by 1970s. A breakthrough application, different types of text from handwritten text makes the fast practical industrial application. So from handwritten, suppose we what we use today, we will use like Google Lens, isn't it? So like from text, image to text, those kind of applications were practically being implemented by early 1970s. The accuracy level were very low, but still it have came into a fast commercial use. Today's mature technology, reliable and mature technology platform. So today our technology is much more reliable because the false alarm is very much less. Generates huge cost of saving across industries because it's a part of a artificial intelligence. It's like things like and behaves like human, and we get the result very fast. Save significant time of various application, continuous evolution and improvement. Yes, that is very much important. Still we are like developing the computer visions and research are being going on. So industrial applications where in practical day-to-day life we use computer vision. Retail and manufacturing, transport and insurance, media and agriculture, healthcare and sports, banking and finance, augmented reality, home security, management. So these are some of the industry applications. Specific application examples. So these are some of the important applications where we can use computer vision. Detection and monitoring. Suppose now in earlier time, what we have CC cameras which was used DVR, isn't it? That was a primitive and traditional type. Now we have like we can detect the motion of the human, and the like cameras are Wi-Fi, isn't it? So development are going on. So what how computer vision help us? There are some of the points are here. So detect in detection in manufacturing, intruder detection system. Next is mass detection compliances. So nowadays we all know that artificial intelligence has developed a very in a strong way. If you use mass, still it can recognize the person. Tumor detection in medical imaging. Yes, in pattern recognition and computer vision helps in various medical fields like heart disease prediction and any like coffee bean prediction. Different medical fields, like we are being using computer vision. Crops and plants monitoring. Many of my friends are doing postdoctorate in crops monitoring, disease prediction. So vehicle classification and traffic analysis. Yes, can you give a example of vehicle classification and traffic analysis? Anyone?
Sir, in toll booth, I guess.
Sorry.
Sir, in toll booth.
Yes, definitely. In toll, if you like talk about Kaziranga corridor, so we have some speed limit, isn't it? They used to like recognize our number plates, and like the timing between in and out timing are being recorded. So we need to maintain a constant speed. So that is what a pattern recognition and computer vision are being implemented. All right. And of course, in toll also, the computer visions have been implemented. Security and quality control, customer tracking system, thief detection and prevention, manufacturing quality control, medical diagnosis, imaging, autonomous vehicle navigation, real-time surveillance. So these are some of the day-to-day life and practical examples. Okay. Core computer vision tasks. So object classification. So these are the some of the core computer vision tasks. So object classification, recognizing broad category of objects in photographs. So we different photographs, by rendering the images, we can classify the images and objects. Objects identification, identify the different types of objects. So among the different objects also, we can identify different features. Suppose we have different collection of purses, like whether it can be black or it can be gray or red, or like purse have different brands. So we can recognize all those things. Okay. Object verification. Yes. Suppose we need to like there are different fast copies like Adidas, we have some fast copies, isn't it? We human cannot detect some of them, but machine nowadays it can detect whether it's a fast copy or it's the original one. So verifying the presence of the objects in photographs. Object landmarks detection, detecting key points of the objects in the photos. And another practical use, if I say, suppose you like a t-shirt or any other like clothes. So if we try to upload those photographs in Google Lens, automatically we can get many options in the online platforms, isn't it? So those are some of the core examples where we can use computer visions to recognize different images in different sites. Object segmentation, segmenting pictures belonging to object in images. Object recognition, recognizing objects in pinpoints their locations. Okay. So computer vision models. So that is the different algorithms I was talking about. Mainly, we need to know the two algorithms. First of all, we need to know ANN. So ANN stands for artificial neural network. Okay. So first of all, we need to know what is artificial neural network and how we get the result. Okay. So it stimulates the human brain's information process. So as we human things and have the perceptions, similar way artificial neural network, it behaves the same. It consists of inputs of hidden and output layers. So there are different outputs. Suppose let us take an example. Okay. So we have three images of cats, 1, 2, and 3. So we will break into different categories. Suppose the first cat is in white color, second one is in black color, third cat is in black or brownish color. Okay. So what we will do, we will label them into different categories. Suppose all the heads, what we will label it here, first, second, and third. This red hidden layer we won't show to user. That is our algorithm. This is the head part. This is, suppose second one is the like the body. This is the leg, and this is the tail. In this hidden layer, we will break and try to label them and identify each of the weightage by different calculations. There are metric fusions and different algorithms are there in between. and hidden layer will be working here. And later on, we will, when we later on it will combine and we will get some result. And after that, when we upload a new picture of a new cat, it easily identify, we can easily identify whether it's a cat or any other objects. Okay, in the hidden layer, we try to label them different parts. So this is what we can understand with the help of this figure. Again, I will explain. These are the different inputs. Input 1, if input 2, input 4. These are the different inputs. So these can be different objects, and these are the hidden layers. Okay, so in these different hidden layers, the machine will calculate and they will label in different ways. Suppose the head, leg, and different ways, and finally it will give a output. And based on that output, whenever we will render a new image, it is easily classification is done very easily. Have you understood how ANN works? Or shall I repeat?
So can you repeat that once again?
Okay, fine. Suppose we need to identify a human. That is our challenge. Okay, we have what we have done. We have taken different continent, different persons. Suppose this input one, we have some Asian people. So in the physical observation, if you observe the people from Africa, the people from England, people from Greece, they are taller, shorter in physical ways. They are similar, but like in if at a fast perception of the human, we can easily classify, isn't it? But machine cannot classify. So our main objective is to identify whether it is human or not. So what we will do, it will break down into different parts. Suppose in the first layer, it will break only the nose. So the nose from Asia, nose from Asian continent, nose from Europe, nose from like any other continent, it will combine. Then legs, every part it will break and label them. Okay. So again, it will merge, different objects, it will merge. So they will merge together and they will combine and give a certain output. After giving certain output, whenever we will upload any picture from any continent, a human being, the machine will distinguish that this is not an animal, this is a human being. Okay.
Yes, sir.
Okay. So let's try to figure out that ANN have different types. That is feed forward, CNN, RNN, and MNN. So these I will not go in depth the different types of artificial neural network. I will explain only CNN. Okay, that is a traditional method. So this is a CNN method. Okay, which stands from convolutional neural network. So what are the functions and key features of CNN? I have mentioned it here. So it's a hierarchy learning. So CNN automatically learns the hierarchy of the visual features from lower level edges and texture in early layers and higher level objects concept the deeper layers. So it learns from the lower levels and gradually it goes to the higher level. This mimics how human visualized process work, eliminates the needs of the manual features in engineering. Spatial invariance and local connectivity. Through convolution and pooling operations, CNN achieves the translation variance and detecting objects regardless portions and scales in invariance. Local Receptive fields allows the network to focus on the spatial relationship between the nearby pictures. So in here, just imagine if we want to label each and every like object, the size becomes very much large, isn't it? So what it does, it eliminates the unwanted things. End-to-end learning and vision tasks. So it helps to learn. CNN enables to direct learning from the raw pictures and final perception of through CV tasks like image classification, object detection, semantic segmentation, face recognition. So these are the different applications where we can use CNN. This unified approach, the revolution of computer vision. So earlier stages, we have used CV by using CNN method for this applications. This unified approach revolution. So from that uh, traditional method, we have revolved and we have come across like different advanced method like transformers. So this is what how human being thinks, and I have shown the category between the human and the machines, the perception of thinking. So this is a neuron, isn't it? This figure is in biology books. We have already came across these different like functions of the human brains. So this is a dendrite, nucleus, cell body, axons, and here we get the what output. This is the input layer and this is the output layer. So similar way as I have explained you both ANN and CNN, isn't it? So here itself we give different inputs. We try to label it up. X, X1, X2, X3. So in between there are different hidden parts and we will try to figure out a part which is Z, which is the linear function. Okay. And which is from Z, we also have a activation function. Means from the Z, we have evolved a result. We have got some of the perception. Whenever we will render different images, we will get some like perception that this is object can be classified as a cat or dog or different objects or different fruits, isn't it? Suppose we have rendered the images of a apple. So this was the apple from like Kashmir or different places. So by giving different weights and different algorithms, we can get a perception that is Z. So Z is always proportional for the activation function F. Now, whenever we will give a another uh, images of like apple, it will automatically give out the result and label it as a apple. So the future is visual. So now already I have told you from 50% to 99% we have got a result, isn't it? So with the help of computer vision and pattern recognition. So computer vision has revolutionized how machine understand the images. Applications span virtually even industries, continuous growth and innovations expected from specialized course from deeper learning and considered career opportunities in booming fields. So the applications we can use in different fields. Okay, so this is the end. Now we will go to the practical part. So for the practical part, I will share the CSV file and everything. Before that, I will explain you. Huh? Am I audible? Hello? Kindly response.
Yes,
Am I audible?
Yes, sir.
Okay, fine. So you can like do small mini projects, and you can get the data set from Kaggle also. Okay. I have not used Kaggle. I have used different APIs. I will let you know what I have used for my projects. So you can use Kaggle. Okay, here different data set can be found. All right. From Kaggle, you can like download this dataset which is called Animal 10. So from Animal 10, if you like try to download their dataset, already they have supervised and labeled those dataset. Just you need to code, and whenever you try to render different images like cats, dogs, so you can get your result. So what they have done, it contains 28K, means 28,000 medium quality animal images are there, and they have categorized it. Already they have labeled it. What they have labeled? They have labeled dog, cat, horse, spider, butterfly, chicken, sheep, cow, squirrel, and elephant. So whenever you try to give different images, suppose you gave a like uploaded a new images, a white horse. Okay, the machine will immediately give you the result of horse. All right. So you can do some of the projects using this data set. You can try by it yourself. Okay. Okay. So I have imported different libraries. So I have used NumPy, Pandas, Matplotlib, Seaborn, Sklearn. So I have already imported different libraries. So after that, what I have done, I have classified. I have tried to label different types of label different types of classes of different objects. So what are the objects I have tried to label? That is dog, cat, human, tiger, sheep, and bird. Okay. After that, what I have done, I have given the image height because we need to understand the complexity of the algorithm, isn't it? If we increase the size and do not give a batch size, what will happen? Our algorithm complexity will be very much high, and we won't getting a like result very fast. Okay. And we have used what? We have used traditional method. What is the traditional method? CNN. Okay. So here we have used CNN, and we have used Keras. We have imported Keras. Then we have used some activation functions. These are some of the layers. I have already explained you what are different layers, isn't it? These are some of the layers. I will show you just a minute. These are some of the layers. So I have given weights to the layers. So this each and every layers, then we should give some of the weights. So I have given them some of the weights. Okay. Then after that, I have used the activation function as softmax. This is a different like huge topic. I cannot explain in one day. So we have used another activation function which is softmax. Okay. So we have uploaded the images, and the image what they will convert, they will classify into RGB. Okay. Red, green, and blue. So now you will use some of the convert into array and try to normalize, and later on it will try to predict what, whether it's a dog, cat, or any other, and they will show the confidence level. Confidence level means what? The prediction level, because I have told you there might be some of the false alarm. Okay. So in this model, they After that, the model will create and give out the result. So these are some of the result we will get. So let me run and show you. Okay, let me run and I will show you. So it is taking a little bit time. Yes, it's done. So we have used different methods and we have tried to level it out. So now after this is the main part. So in this part, what we will do, we will try to upload our images, different images. So what I have done, I have already uploaded the image. Okay, let me upload one more time. Okay, we have chosen a path. Okay, let me show you. Let me upload a image. So this was the figure of the dog. Let me upload. So have you seen? So dog confidence is what? It is high. And it is showing a bird. It is also showing a prediction of a bird. So this is also a false alarm, isn't it? So this is the CNN method to like predict whether it's a dog or it's a any other animal. So in this way, we can upload different images. Let me show you one more time. Let me run. Okay. Sometimes it gives a false alarm also. Suppose this is an example of a tiger. So let me see what type of result it gives. So have you seen the confidence it's giving a false alarm? It's showing as a human. Have you seen? We have a label which is called tiger, but they have shown as human. Have you seen? Can
Yes.
anyone acknowledge this one? Have you
Yes, sir.
understood what is false alarm?
Yes, sir.
Yes. So this what result we should get? We should get the prediction as tiger, but the prediction which we are getting as 38% as human. So this is a false alarm. So that's the reason why I am talking CNN as a traditional method, because the 50% of the result we get accurate and another 50% we get false alarm. Have you understood why I have been talking about 50% earlier time, and over the decade how we have improved from 50% to 99%? I will show you. So that this is the CNN method where we used to get only 50% a correct results. Okay, so do you want to try these codes? Shall I send in text form in WhatsApp?
Yes, sir.
Okay, fine. So what you need to do, I will copy whole code and I will send you in the text format. Okay. In the notebook, I will send in a text format. Just simply you open this Google Colab and try these codes. Okay. If you find any difficulties, I will help you. And it's error free by the time. It should be work. Let me stop sharing and I will send you in WhatsApp. Just a moment. Okay. Just wait, I will share in the WhatsApp, okay? At the time, please try to open Google Colab. So all the libraries I have given you, you need to like copy and you need to paste. The lines which have you have been you can see. Have you received? Can anyone acknowledge?
Yes, sir. Received.
Yes. All, the different lines are all like libraries. These all are libraries. Now in the next part, I will share you the code for CNN algorithm. These lines, whatever I have sent you in WhatsApp, please try to run in Google Colab. Now in the WhatsApp, I have shared CNN algorithm. Please try to copy and run. Okay. That is the second part. And last, for uploading the images, I will give you the code. Just a moment. I have also upload the codes for uploading the images. Please try in your Google Colab and you need to give different images of dog, cat. Okay. Let me share my screen again. Just wait.
Yes, sir. Done.
Have you got some result? Can you share and show us the result?
Sure, sir.
Great, 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 great. So what is the, can you drag little bit down? Yes. So have you seen the false alarm? So you have uploaded the image of dog, but the prediction is what? The prediction says it's a sheep, isn't it? So that is what? That is a false alarm. Okay. So that's the reason why we will not use CNN for at the present time. We will use different methods, different transformer models. Okay. Okay. Thank you, Bishal, for sharing the screen. Okay. 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 So in the next part, we have been using some algorithms. Some advanced algorithms in the terms of we have used, just a minute, we have used different methods. I will tell you. We have used CNN algorithm, ANN algorithm, transformer model, Gemini. Gemini is also a part of a transformer model. Okay. Ensemble model, and evaluating all the results, we will get compare and get a result. So I will explain you the code one by one. Just a minute. So we have imported different libraries. As we have seen, as Bisal, you have tried, we have got lots of false alarm. So to avoid the false alarm, to get the 99% result accurate, we'll use different advanced techniques. We'll use traditional technique also, and we will use advanced technique so that we can compare the result. Okay. So the same way we have classified dog, cat, human, sheep, and birds. We have labeled 5 classes. Okay. And we have created a Gemini API. So to create the Gemini API, you can go to the your Google account, and you will get your Gemini API key. By pasting your Gemini key here, you can configure and you can use Gemini Transformer. Okay. So we'll be using like 1, 2, 3, and 4 models. Okay. First of all, CNN model, ANN model, Vision Transformer, and Gemini AI. These four models we'll be using to classify and get much more advanced result and to reduce the false alarm. Okay. I have already told you to like use your own name, which is Nitro. I don't know. Who is it? Okay. So have you understood why I have used Gemini and Vision Transformer? Because these are some advanced algorithms. Okay. So we'll be using different layers, activation functions we'll be using. Next, we will compile them, and we have used ANN models. We have used transformer model. These models, these are different layers we will be using, and activation functions, and different uh, activation functions and different weightage will give different. So like the density here and density like for uh, different models, we will try to keep it same, the weightage. Then we will be using Gemini classifier, and we will use our key. And next, we will prompt our load the image. We will load the image in our part, and we will try to figure out by these 5 categories, whether it's a dog, cat, human, sheep, or bird. And next, by getting it, we will get the different results. These are some of the codes for the result predictions only. Okay. So after that, we will try to run. As soon as we run this, we will get this as a result. Okay. In between here, we need to add the API key. So when you need to go for the API key, you need to click here and you need to make your own API key. Just clicking to the link, you will get the API key here. Just click here, create the API key. You can create your own API key. Okay. So by pasting the API key, you need to add this, like uploading these 2 codes. Then you need to choose a file, and you can, let me show you. It's error because we need to we need to run the previous code. Just wait. it will take some time for execution because the complexity will be higher than CNN model. As we have used here the 4 models, isn't it? So it will take much more time compared to CNN model. As your complexity of your algorithm increases, the execution times automatically it will increase. Okay. Have you seen the execution time is much more than CNN? Yes, they have asked the API key. Okay. Let me stop sharing. Let me go. Just a second. I will paste here the API key. Okay. Just a minute.
So what is an API key?
So API key is a like it's a application programming interface. In short, suppose let me give you a suitable example. Let's take the example of ChatGPT. Okay. So you want to use ChatGPT like you use ChatGPT very rarely. Okay. But you don't need to you don't want to pay 2000 rupees per month because your usage is less, isn't it? So you want to pay number of clicks, number of uses you want to pay. So that's what the API key, whenever you will call the request, it will count on the number of count you have to pay. So API key is what? It will calculate some of the token amount of like token amount of like clicks it will count, and it will on the basis of the uses you will be able to use the application. So I am using Gemini API. So they have some limits. So what is the limit? I will show you. Just a minute. Okay. Let me share my screen. So this is how it's look like. Get API key. So I have created my API on 3rd July and this is the free plan. So set for a free plan billing. So if I click here, just a minute, it will show you how much I can use daily, how much request I can put here. So 300 free credits, try Google Cloud. Okay. So it has some of the limits. After that, I need to pay for it. So it's a number of like counts of uses. It will give out the result at some amount of time. Have you understood what is API?
Yes, sir.
Another example, suitable example I will give you. Just wait. Suppose what is the cost of a cake? Can you tell me a normal birthday cake?
300.
Okay, great. But you cannot eat the whole entire cake, isn't it? Can you eat the entire cake?
No, sir. No, sir.
Okay. So in the bakery shop, what you have some of the pieces or slices of pastries, isn't it? So for the slices of of the same cake, you need to pay only 50 or 40 rupees for the pastry, isn't it? So API is somewhat the similar. The amount of it depend upon the number of uses, and whenever you want to use more, like you want to have more pastries, number of pastries, the number of amount it will get increase. That's how API is related. Have you understood?
Yes, sir.
Okay. So this is what I have already like paste my API key, and still it's in running phase. Okay. It will try to like finish it up some of the libraries. Let me wait for some of the time. Okay. We are ready. Okay. So here we have understood the complexity of the algorithm is much more higher than CNN. Now the similar image which we have got the false alarm, the tiger. Now we will paste. Let's wait for a result. Okay. Let's wait for our result. So as we have uploaded the image, CNN it has labeled as bird. It's a false alarm. So ANN has given a label at what 33% as what sheep, and transformer, this is the whole bird, sheep, transformer has labeled it as a cat, but you have not get the Gemini result. Okay. But in the Gemini, we will get it labeled as tiger. Okay. Let me run one more time because the previous we have some. Okay, there is problem with some Gemini. Okay, I need to fix this Gemini transformer. So in the meantime, I will show you another example which has already been done. So I have uploaded the image of the bird. So as you can see, this is the result CNN. This is the like ANN transformer we have get labeled as cat. This is the false alarm. These are the false alarm. But whereas in Gemini, it has a confidence of 100% that it's a bird. Okay, so how they have given also the reason, the image shows the bird with the feature wings and the beak and clearly visible body structure. So ensemble result, it gives a result of a bird, and we have compared it with different models, and by the comparison of the different models, Gemini gives a 100% assurity that it's a bird, and confidence is 44% by combining all the methods. So this is how Gemini works. So there is a problem with the API key. So I need to fix it. But the code is error free. Huh? So this is what all about CV. Have you get something like what is the concept of CV? Have you understood?
Yes, sir.
Okay. So I will share the second code also. You need to like create your own API, and whenever you will paste it, I have shown you how to paste the API key. Whenever you will paste it, and you will get the result. Okay.
Yes, sir.
Okay. So is there anything to ask? No. So thank you so much. So some of the students have been asking me how to like your projects has been already been done. So how to upload. So by tomorrow we will be giving you some Google Forms. So in Google Forms you need to paste the URL. Okay. So thank you so much. So you can leave for today's session. Thank you.